We are Team Future founders from DY Patil College of Engineering, Akwati, and I am Manasi Karankal from the same team. Our problem statement ID for Smart India Hackathon is SIH1322, and our problem statement is use of coconut shell and husk as a filtration media. The theme of this project is environmental engineering. Post solution: to create a rapid sand filter with partial or complete substitution of sand with coconut husk and coconut shell as a filter media. We all know that rapid sand filter has been used on a large scale recently for water filtration purposes, and it is also efficient in many ways. This filter uses sand as a filter media, and we know that sand is a finite resource and not available in a huge amount. And scarcity of sand is also a topic of concern, which can cause adverse environmental impacts. Hence, considering all the above facts, we have decided to replace the sand either partially or completely with coconut shell or the coconut husk. Then, addressing problem. First one is the use of waste generated from the coconuts, reducing the load from waste management bodies. As we know that the temples are the huge source of generation of coconut waste, and the disposal and management of this waste is also a challenge. Also, there are other sources through which coconut related waste is generated. So, hence, by using the coconut husk as substitute, we can tackle the problem of waste management. Second one is sand as a finite source to reduce the dependency on sand as a filter media. Sand, as we have already discussed, is a limited resource, and depletion of sand can have negative impacts on the environment. So, hence, the use of coconut husk and shell instead of sand can be beneficial. And third one is reducing quantity of water for backwashing. Okay, so for backwashing process in rapid sand filter, it usually requires 10 to 15% of total treated water, the treatment plant, and therefore huge amount of water gets wasted. So hence by using the coconut husk, we can actually reduce the water required for the backwashing. Then technical approach. So in technical approach, we have technologies. So here are the various technologies that we are going to use. The first one is tasting equipments. So in the testing equipments, we are going to require nephelometer for measuring the turbidity of water, then pH rod for knowing the pH, tintometer for monitoring the color, stopwatch to measure the filtration rate, Imhoff cone to measure the amount of settlable solids. Then the chemicals that we are going to require are methyl orange, phenolphthalein, acetic acid, potassium iodide solution, sodium sulfide solution, etc. Then methodology and implementation. So in methodology and implementation, the bottom layer that we are going to use, or like we are going to provide, is a layer of coarse gravel ranging between 20 to 30 mm. The reason behind using this coarse gravel as the bottom layer is to sustain the load from the upper layers. Then above that layer, we have fine gravel layer ranging from 4.75 to 20 mm. After that, we are going to use coconut shell. Firstly, we are going to break the shell following by its grading and sieve analysis to obtain two grades. So the grade one, which will range from 4.75 to 10 mm, and the grade two ranging from 2 to 4.75 mm. Then we are going to require coconut husk of 2 micron, and for that we'll need to grind the coconut shell. So feasibility and viability of using coconut based filter. So the challenges. So following are the challenges faced while using coconut husk as a replacement of sand. So the first one is pre-treatment is required to propose filter media. In this, we need to do a pre-treatment on the coconut husk and shell, such as breaking it down, oven drying for 24 hours, and therefore it is a challenge for us. Then the second one is excessive microbial growth. The growth of microorganisms on the upper layers can be seen, which can be challenging to remove them. Um, and the third one is liable to decomposition. The organic decomposition of the coconut shell can occur, which can be again a challenge for us. So, yeah. So, solution. Um, the unique properties of the material, that is the coconut base material such as the coconut shell and the coconut husk, is that they have high porosity, then the absorbent capabilities are also great, then the biodegradability of this material is also very effective, and thus because of all these properties, these materials are actually effective in removing the contaminants from the water. Then impacts and benefits. So, benefits of coconut based filters. The first one is reducing dependency over sand of rapid sand filter. So, as we have already discussed, that the scarcity of sand resources is there, and therefore the coconut based filters can be an excellent solution and great alternative to sand. Second one is less need of water for backwashing. As we have previously discussed, the amount of water required for backwashing in coconut based filters is less as compared to the rapid sun filters. Hence, the water consumption also gets less. The third one is economical. Um, the coconut based filters, they are actually economical because um, mostly they are used at the small scale, and economical filtering can be done with the help of these filters. Then low maintenance. Other than pre-treatment, no other huge treatments are required in this filter, thus making this types of filter a low maintenance. Fifth one is, in the addition to all these given points, the rapid sand filter can be used in rural areas where there is lack of water treatment plants and unavailability of clean water. Therefore, the coconut-based filters can be used at local levels too. Then impacts. So the coconut-based filters can be used even in the case where the source of water is highly polluted or contaminated, as it is given here, that access to safe water can be done even with contaminated water source. Then decreasing dependency over government bodies for potable water supply. So with the help of these coconut based filters, we can also reduce the need of relying on government bodies for purification of water and drinking water supplies. Okay, so here are some details or links of the reference and research works which we have adopted. Okay. So thank you. This was all. Thank you.